Hey guys, in this video we are going to be talking about the procedures for solving a system of inequalities by hand. So last class we talked about how to use Desmos to find the solution to a system of inequalities. And this class we're going to use that same idea but do it by hand instead of with technology. So we're going to start by talking about how to decide whether or not an ordered pair is a solution to a system. So we're given this graph, and remember, the solution to a system of inequalities is where the shading overlaps. So if you see on this graph, there's only one section of shading, and that's where it overlaps, because in reality, the shading for the solid line would have been this whole area here, and the shading for the dashed line would have been this whole area here. So the overlap is right in here. So any ordered pair that is in the shaded region is automatically going to be a solution. If it lies on the line, it has to be, or for it to be a solution, it has to be on the solid line and touching the shaded region. So anything around here is fine, but anything on the dashed line is not. Therefore, the intersection of the two lines is also not a solution because one of the lines is dashed. Anything in the non-shaded region is not a solution, and anything on the lines that are not touching the shaded region, even if the line is solid, is not a solution. So let's take a look. The first point we have is 8,2, which is right here. Now 8,2 is directly in the shaded region, so this one is a solution. Then we have 6,1, which is right here. That is in the non-shaded region, so that is not a solution. 3,3 is our intersection point, which, as I mentioned, cannot be a solution because one of the lines is dashed. So we're going to say no to that one. Then we have 5,7, which is right here on the solid line and touching the shaded region. So that one is a solution. 0,4, on the other hand, not only is it on a dashed line, but it's also not touching the shaded region. So that one is not a solution. All right, so let's dive into how to solve a system of equations by hand. Okay, so remember, we're looking for where the shading intersects. So first, we have y is greater than negative 2x plus 2. The starting part of this is very similar to graphing an equation in that you use the y-intercept and the slope to find points. After that, you have to decide, should my line be solid or should it be dashed? So since there's no or equal to line underneath this symbol, my top inequality is going to be dashed, but my bottom one does have a line, so that means it's going to be solid. So let's go ahead and graph. The y-intercept of the top one is 2, and then we have to go down 2 and right 1. Now, since we don't actually care about the intersection point, getting 3 points is sufficient enough to make the line. But remember, this one is dashed. Now, to decide for the shading, one thing that I like to do is just pick a point that is definitely on one side or the other. And by side, I mean side of the line. I like to choose numbers that are going to be easy to work with, so I try to avoid the negatives. I'm just going to pick a point right over here. Let's do 6, 0. Okay? So what I'm going to do is I'm going to plug 6, 0 into my inequality to see if it makes it true. And this will help us decide what side of the line to shade. So 6 is my x and 0 is my y. So that gives me 0. Let's see, I'll write that up here. 6, 0 is the point that I chose. This is x, this is y. So 0 goes in for y. And then I have negative 2 times 6 plus 2. All right, so 0 greater than. Negative 2 times 6 is negative 12, plus 2 is negative 10. It is true that 0 is greater than negative 10, so I'm going to shade the side of the line that has the point that I chose. Here's the point that I chose. So I'm just going to lightly put in some lines here, so I know that that is the side that is shaded for that line. Now let's go ahead and do the other line. I'm going to use a different color. If that's something that you want to do, by all means, please go for it, but you definitely don't have to. All right, so my y-intercept is negative 1. My slope is 1/3, so up 1 to the right 3. This time my line is dashed, solid, like this. And I'm going to choose a point that I can use here to decide which side to shade. And actually, 6, 0 is not on the line, so I'm just going to use that same point again. It doesn't always work out that way. So 6, 0. This time my inequality is y less than or equal to 1/3 x minus 1. So I'm going to plug 0 in here. less than or equal to 1/3 times 6 minus 1. 1/3 of 6 is 2, minus 1 is 1. 0 is less than 1, so this is true, which means I'm going to shade the side of the line that has 6, 0, which is this side here. Now I want to go all the way across. I want to pretend that my maroon line is not there. So you don't want to just stop where that line is. You want to go all the way across. And the reason for that is so that you can see where the shading intersects, which if you look, this section over here is the section that has both blue and maroon. So I'm going to take a pencil and I'm going to shade that in nice and dark so that I know that that is my solution region. And also, when I go to read your work, I'll know for sure that you know where the solution region is. Okay, so that's it for that one. Let's try another. Okay. All right, so this top one here is 1/4 x. So that means my y-intercept is 0. I'm going to go up 1 and to the right 4. And my line is going to be dashed because there is no or equal to line underneath the sign. And I don't know, let's see, 4 is my denominator, so I want to pick something that's divisible by 4. So let's do 8, 0. So 8, 0. And again, you don't have to choose an ordered pair on the line. You can pick any point that you want as long as it's not on, and by the line I mean on the axis. But you don't want to choose a point that's on the line that you drew. All right, so I have y is greater than 1/4 x. So 0 is greater than 1/4 times 8. So I get 0 is greater than 1/4 of 8 is 2, which this time is not true. 0 is not bigger than 2. That's false. So when that happens, I don't want to shade the side that has the point that I chose. So I don't want to pick this side. I'm going to shade this side instead. Okay. All right, let's go ahead and graph the other line. It starts at 4, which is up here. And then I go down 1, right 1. And this line is solid because it has the or equal to sign. And once again, it looks like I got lucky. Let's make sure. Yeah. I can use this 8, 0 again if I want to, but you definitely don't have to. So let's just go ahead and do it. 8, 0 again. So I have 0 less than or equal to negative x, so negative 8, and then plus 4. So now I have 0 less than or equal to negative 8 plus 4 is negative 4, and 0 is not smaller than negative 4. It's not equal to it either, so that's not true. So once again, I do not want to shade the side that has the 8, 0 on it, so I have to shade this side of my blue line. And remember, it's all the way across that blue line. So that means my intersection is right here. So I'm going to use my pencil to make that nice and dark. So I know that that's where my solution is. All right, let's try another. All right, first inequality starts at 3. And it goes down 2 to the right 1. Down 2 to the right 1. This one is solid. It has the or equal to line. Okay, let's choose a point not on the x-axis this time. Let's do, I don't know, 6, 2 sounds good. All right, so we're using the point 6, 2 for the top inequality. So now I have 2 is greater than or equal to negative 2 times 6 plus 3. So 2 greater than or equal to. Negative 2 times 6 is negative 12, plus 3 is negative 9. 2 is bigger than that, so that is true. So I'm going to shade the side with the point that I chose, so that's this side here. Okay. All right, the second inequality starts at negative 2, and it goes up 1 to the right 2. And this time it is dashed. Okay, let's pick a point that's different from the one we used here. Let's do, I don't know, I like to keep it positive. So it should be divisible by 2. So let's do 8, 1 this time. Okay, so 8, 1. So I have 1 less than 1/2 times 8 minus 2. 1 less than half of 8 is 4, minus 2 is 2, and 1 is less than 2, so that is true. So I need to shade the side of the line that has 8, 1, which is this side right here, meaning that my solution area is right in here. Okay, so that would be the solution to the system. Let's try it one more. Okay, so this one starts at -4. And this slope is 8, so up 8, right 1. And it won't fit another one on there. It is dashed. And let's pick, I don't know, let's go smaller this time. Let's do 3, 2. Okay, so over here we're using 3, 2 for the top inequality. So that gives me 2 is greater than 8 times 3 minus 4. So 8 times 3 is 24, minus 4 is 20. This is false. 2 is definitely not bigger than 20. So I don't want to shade the side with this ordered pair. I'm going to shade this side instead. Okay, so then when I get to my other inequality, it starts at 1, and I go down 1, right 2. And this one is also dashed. And let's see, it's got a half in front, so something divisible by 2. Let's use 6. I don't know, 6, 6 maybe? Doesn't really matter. So 6, 6. So now I have 6 is greater than -1/2 times 6 plus 1. 6 greater than. -1/2 times 6 is -3, plus 1 is -2. This one is true. 6 is definitely bigger than -2. So I'm going to shade the side with this dot here. So that's this side of the line, all the way across. So that means that my solution region is right in here with all of this mess. And that would be the solution to my system. And that is it. That is how you solve systems of inequalities by hand.